Hey guys, welcome back to the shop. My name is Adam, and today my buddy Paul has come by and he is going to give us a hand and talk about some hydraulics. So we've got a few different things that we're going to discuss with this system here. This is a really nice hydraulic training unit that shows you all of the fundamentals on a hydraulic system. And Paul is going to go over this. So by the way, I wanted to point out that Paul has been designing hydraulic systems for a very long time. He has a lot of experience in them, and also with troubleshooting and preventative maintenance and that kinds of things. So we've got a number of things over here on another table that you can't see yet, that some other components and parts that we will get to later, and zoom the camera in over there so you can see all that. And I've got some things here. It's going to be 4 sessions, and your first session is going to be components of hydraulic system and fundamental elements that govern all of hydraulics. Okay. Your second session is going to be component operations and how they fail. Third session is going to be inspection and troubleshooting. And the fourth session is going to be how to prevent the most common hydraulic accidents. So we're going to let Paul step in here and go over all of these subjects here. And I hope that this helps educate people on a hydraulic system. And not only the viewer that's watching this, myself included. I'm getting something out of this today. And he showed me a few things on this, and it's really interesting to learn how these systems operate and the fundamentals of them. So we're going to go ahead and we're going to let Paul step in and start talking about the system components here. Okay, hope you guys enjoy.
Hi, this is Paul from the shop, and Adam's invited me by to talk a little bit about hydraulics today. And as you can see, we got a really nice hydraulic demonstrator here to be able to show you some things that people struggle with out in the field when they're trying to troubleshoot and things like that on a hydraulic system. So what we'll do, I've broken this down into 4 different segments. The first segment is going to be components of a hydraulic system and some things that govern hydraulics, the fundamentals of all hydraulics like pressure and force and flow and speed and things like that. And the second section is going to be about component operation, how each one of these components operate and how they fail. I got a little bit of background and reliability, so we're going to talk about a little bit about how these items fail and how to prevent that. And then the third session is going to be about inspection and troubleshooting. That's always a common problem and of interest out in the field. Over the last 30 years I've done this. So a lot of people don't realize some things that they have to have for troubleshooting. So we'll go over that. And then the fourth session is a little bit on safety, most common hydraulic accidents and how to prevent those. Definitely don't want anybody getting hurt out there doing this, so we'll talk about that. When I do a video or a class or something like that, I want to make absolutely sure that there's an objective that I want people to walk away with. So in this particular session, components of hydraulic systems and fundamental elements that govern all of hydraulics, what I want you guys to walk away with on this is, after completing this session, you should be able to field identify the 10 essential components used in heavy industrial hydraulic systems: reservoir, oil, prime mover, pump, relief valve, directional valve, linear actuator, which is a cylinder, a rotary actuator, which is a motor, and fluid conductors like your tubes, hoses, fittings, things like that. And understand the fundamental elements that guide all of hydraulics. So if you walk away with understanding that pressure is force and flow is speed, you'll understand a lot more than most folks do when they're out there trying to troubleshoot hydraulic problems. All right, what we're going to do now is talk a little bit about different components in a standard hydraulic system, industrial hydraulic system. So the first one you have is a reservoir right here. And the second thing you have is the oil inside the reservoir, and you'll know how important that is by the time we get finished with all these sessions. Next is called the prime mover, which is usually an electric motor over here that actually drives the pump. Next thing we have is the coupling that's connecting the pump to the electric motor to allow the pump to turn. Alright, the next thing is a hydraulic pump, and you'll notice that the pump is mounted below the oil level in the tank right here, and that's always the best way to do it because oil has weight to it and it keeps the pump primed whenever the pump is below the oil level, so that's always the preferred method on the pump. Alright, so then you move up here to the safety relief valve, and what the safety relief valve does, it protects the system from overpressurization. Okay, so next thing we have is the filters. We got a filter back here, it's a little difficult to see, and then we have inside the tank here a strainer. And then as we go through this into the next couple of sessions, you'll understand what a strainer does and how they fail and things like that. Then the next thing we have is a directional valve. Here's a directional valve here, solenoid operated, and then over here you have a manual directional valve. You actually have to pull those with your hand. Next thing we have is a linear actuator that comes out in a straight line. And the next one is a rotary actuator that actually goes around and around. So in hydraulics, you only have two choices. You can go in and out or around and around, and that is it. So that's what makes that really simple for me to understand, and should make it simple for you guys to understand as well. Alright, the last thing that we're going to talk about in the standard things that come in a hydraulic system is the fluid conductors, and that is your hoses and tubing and fittings and things like that. Of course, these components wouldn't do you any good unless they're actually hooked up and you have oil flowing through the system. Okay, so there's your inlet hose right there coming from your tank to your pump. Then you come out of your pump with this hose right here into this block here. Then you come with this hose right here into your directional valve. And here's your two work lines right here, your A and your B work line that go out to your hydraulic cylinder. And then here's your tank line that actually goes back through the filter to the tank. So that's the essential components of any hydraulic system in order for it to function, is those components right there. Alright, the definition of hydraulics is a means of transmitting power by pushing on a confined fluid. As you can see by these hoses and the way all this stuff is hooked up right here, that fluid has to be confined to be able to do work. Whether it's pushing this cylinder out right here or rotating this hydraulic motor right here, that fluid is confined in all these hoses right here. So that's how it actually does work. There's actually three ways of transmitting power. One is mechanical, with gearboxes and chain and sprockets and things like that. The second one is electrical, with variable speed drives and things like that. And then the last one is hydraulics, or fluid power, hydraulics or pneumatics, either one. So this is what we're going to talk about today, obviously, is hydraulics. Alright, back in 1692, a gentleman named Blaise Pascal came up with the law that when you confine a fluid and compress it, it is equal and opposite in all directions. So that is the basis of all hydraulics. When you can't squeeze a fluid. Alright, so in hydraulics what you do is you fill up the back of the cylinder right here with hydraulic fluid, and it's because oil is incompressible, it actually makes that piston move right there. Okay? So what we're going to do now is go over a couple of things that are essential in all of hydraulics to understand. Is the first one is flow makes it go. Flow is speed. If your component is speeding up or slowing down, that is a result of the flow that's coming out of your pump. Okay? So I'm going to turn this system on right here, and what it's going to show you is this pump is pumping right here 1.8 gallons per minute. Okay? So that pump is pumping 1.8 gallons per minute, and I'm not moving anything out here like these hydraulic cylinders or the motor. I'm not doing any work, but the pump is still pumping fluid. Alright, where is that fluid going? Okay? It's going over this relief valve right here and going back into the tank, okay, through this filter back here. Alright, so the only way you see fluid right here is when I actually actuate this cylinder and make the cylinder go in and out. Alright. So one thing I want to demonstrate to you is pumps don't pump pressure, okay? That's one of the things that that's a common thing that people don't really understand. They say my pump's not pumping enough pressure. So what I want to do is go over that real quickly and show you how that works. Alright, you see on this gauge right here, I'm showing 400 psi. Alright, the only reason I'm showing that 400 psi is because I have my bypass valve closed and I'm forcing that oil right here across this spring inside this relief valve right here. Okay? So you'll see if I move this relief valve in and out, the pressure goes up or down based on the resistance to that oil that I'm pushing across that orifice right there. Alright, so what I'm going to do is prove to you pumps don't pump pressure. Alright, I'm pumping 1.8 gallons per minute right here. So what I'm going to do is open this bypass valve and give it an easier path back to the tank. So what you'll see is, you see that pressure drop right there? That's because I'm giving it a free path back to the tank and it's not having to go over this relief valve right here. Okay? So as I drop that, open that up more and more and more, you see the pressure drops down. And now I'm going to open it all the way up. So the only thing you see right here on the gauge is about 10 psi. And the reason you see that 10 psi is because it's taking that amount of back pressure to push that fluid through these fittings and through this block right here and make it go back through this filter into the tank. Alright, so basically what I'm showing you is pumps don't pump pressure. Okay? The only way you see pressure in a hydraulic system is when it has a resistance. Okay? So I'm going to shut this and make the resistance come back, and you'll see that pressure go back up. Okay? So what I just demonstrated is pumps don't pump pressure. One of the fundamental things of all of hydraulics is flow is speed and pressure is force. So what we're going to do now is prove to you that flow is speed. So what we're going to do is time this cylinder coming out at a certain rate of flow, and then we're going to cut that in half and show you that it slows it down. So that'll be pretty evident whenever you see that coming out. Alright, so what we're going to do is, see over here, you see the flow is right at about 1.8 gallons a minute, 1.6, something like that. So what I'm going to do is cut that down to about in half, to a little less than 1 gallon a minute, something like that. And then we're going to time this coming back out, and it should be about half. It may vary just a little bit because of the oil is kind of cold, but we'll give it the old college try here. Alright, that was perfect. It's about 7 seconds. The other one's about 4 seconds, so that's perfect. So the point was that when your flow drops, your speed drops as well. Okay? So it slows down. So when you're troubleshooting a hydraulic system, it's very important to understand the fact that flow is speed, and if you're not moving as fast as you're supposed to, you're losing flow somewhere. And that's the point to this video right here. Okay, what we're going to do now is, we talked about pressure is force, flow is speed. So what we're going to do is prove that pressure is force by using this chart right here. If you go down the left-hand column under where it says bore diameter in inches, go down till you see a 4-inch bore, and then come across to the right until you get under where the pressure says 750 psi. Alright, if you look at that number, that's 9,425 pounds of force that a 4-inch bore cylinder can push at 750 psi. So what I'm going to do is prove pressure is force. So if you double the pressure to 1500, then look over to the right under 1500 and you see 18,851 pounds of force. So there you see that number doubled. So what that means is if you double the pressure, you double the force. Alright, what I wanted to use this chart for is in hydraulic systems, a lot of times people have problems with electric motors kicking out and nobody knows why. I'm going to do something to prove that to you here on this chart. Horsepower is calculated with gallons per minute times pressure divided by 1500 psi, which is a constant. So what that means is if your gallons per minute increases or your pressure increases, your horsepower has to go up with it. So if you look at this chart right here, here's a kind of a neat chart to show you that, sort of demonstrate it. You go down the left hand side of the chart until you find 10 gallons a minute, and then you come across to the right until you get under the 1500 psi, and it shows you that you need 8.75 horsepower in order to run that system. Alright, if you double the pressure to 3,000 with the same 10 gallons a minute, you need 17.50 horsepower. So what that shows you, if you double your pressure at the same gallons a minute, you have to double your horsepower as well. Alright, so what we'll do is do the same thing with gallons per minute. So if you look over here on the left hand side at 10 gallons a minute and come over until it says 1500 psi, you need 8.75 horsepower to run that system. Alright, if you double your gallons per minute and keep your pressure the same, you need 17.50 horsepower to run that system. So what I want you to get out of this piece right here is gallons per minute and pressure determine your horsepower requirements in a hydraulic system. Alright, what we want to prove with this is hydraulic horsepower either goes to work or it goes to wasted energy in the form of heat. And what I've got here is, you look at the picture, I've got an example of that. There's a hydraulic cylinder working down in the bottom of a machine, and over to the right you see I'm measuring the hose temperature at 134 degrees. Alright, and then the one next to that I'm measuring that 90 fitting right there, and it's 3 degrees hotter. So what that shows you is that when oil has to work unnecessarily, like when it's going across a 90 or it reduces down and it becomes turbulent, that is wasted energy in the form of heat, and that is called pressure drop.
Hey guys, Adam. I just wanted to play around with the little test unit for a second before we get ready to put this up. So I decided that I was going to run this little hydraulic motor right here. So we've got the lines hooked to this one valve here, and we'll just we'll watch this little motor run. And we can also control the speed also with the flow control valve. So if you look right here, we'll see this shaft moving. Just using the manual directional valve. That's fun, right? Alright, we can also control I just wanted to play with that for a second and show another element of the training unit here. Paul's already done a good job of showing the little cylinders over here working, so I didn't want to bother with those. So anyway, just having a little fun with it.
All right, I hope this first session, that's the end of session 1, and hopefully that was beneficial to you guys. One of the things I really want to you to walk away with, a takeaway from this particular video, is pressure is force and flow is speed. If you have something in your system that's slowing down, that is a result of your losing flow somewhere. So these flow meters right here, when we get into the troubleshooting part, you'll see how essential those items are, these items right here. Alright, so again, that's a flow meter, that's a pressure gauge, and we went over all the other components. So what we're going to do in the next session is talk a little bit about component operation, how these things operate. Everybody thinks reservoir is just a dumb square thing, but actually it does a lot of other things besides just hold oil. So we'll talk about that in the next session. And not only that, as what you can expect to see when these items fail. When pumps fail, typically 99% of the time it's not the pump's fault when they fail. It's something else that's happening in the system that actually caused that pump to malfunction. So we'll talk a little bit about that in the next session. Thanks very much.